Hello everyone. Today we're gonna solve Newton's second law of motion first problem. This will be our first example, and this example will include pulley system that will use rectangular coordinates of the equation of motion, that the theories that we have studied. So let's see the problem. So learning objective is solve problems that deals with force and acceleration. So if the problem says that we need to work with force and acceleration, we know that you have to use Newton's second law of motion, um, and this problem will be on rectangular coordinates. So in this example, we'll apply the Newton's second law of motion to solve or determine displacement, tension, and acceleration. And you know that pulley system is randomly used in construction sites. This is an example of and also in shipyard they use pulley, and also if you have a heavy machine installed in your apartment or big building, they also use pulley system to pull that up or move the machine. So let's see the problem. The problem says at the instant, meaning the scenario here, at in the setup here, the current location of B and A. So at this instant, the block A, so which is this block A of the pulley system shown in the figure, is sliding downward. So the block is going downward, as the red arrow shows, sliding downward at a velocity of 5 meter per second. So the block A has a downward velocity of 5 meter per second, and the 10 kg block A, so the weight, the mass of the block A is 10 kilogram, is attached with a 5 kilogram block B. So this block B here is 5 kilogram, and they are both attached using this complex, not so complex, this pulley system. If the coefficient of the kinetic friction, so the friction between, if we consider the friction between, you see the block A and the inclined surface, the black line, the friction coefficient of kinetic friction is 0.2. And so we have to determine the tension in each chord. So since the block is going downward, there is a tension upward, because this weight is pulling the block upward. So there is a tension TA. So what is the tension? And also there is also a tension TB, because the block wants to go down. This tension is pulling the block up. So that's TB. We have to find this tension in each chord. Acceleration of block A. So the block A has an acceleration. What is the acceleration of the block A? And the distance traveled by block A. So what is the distance traveled by block A before it come to complete stop? And assume that pulleys, all the pulley we have C, D, and E position. Assume the pulleys are frictionless, so we don't have to consider any friction on the pulleys, and the weights of the pulleys are negligible compared to the block A and B, so we don't have to consider those. So let's see what are the knowns. So we start solving the problem. What are the knowns? The mass of block A is 10 kilogram, mass of block B is 5 kilogram is given, velocity of block A is 5 meter per second downward incline on the inclined plane, and the coefficient of kinetic friction is 0.2. So these are the given. What are the unknowns? We are looking for the tension TA and tension TB of the block, and also the acceleration of block A, and then the distance SA traveled by the block before it come to complete stop. So let's start with block A to solve. So let's draw a free body diagram first of block A. So the block A is this. Okay, it has, since it's on an inclined plane, first it has a tension TA pulled by the cord on that direction, it will have a normal. So the normal is always perpendicular to the plane it's working on, so it will have a normal NA, because of the mass, which is working in y direction, which will be 10 mass, and you have to convert it into weight, so 10z, which is z equals 9.81 meter per second square. So it will be perpendicular, and this is the ground on our axis. So due to this normal force, we will also have a friction force. Since this is going downward, so our friction will be opposite direction of the movement, so that will be 0.2. We know it's multiplied by the normal reaction. So these are all the forces acting, and we also know the angle given here from the inclined plane. So if we take the 10 gram weight downward, so it will be acting downward, and this is 90 degree. So if we draw the angle parallel to this one, hypotenuse, we can get this angle. So if we just convert this line, which is this, we draw a line which is parallel to this plane, 90 degree, so we'll get this one as 5. How do we get 5? 5 is square, Pythagorean law, 4 square plus 3 square, so that's 5. And since it is opposite, right, so it will switch, the arm will switch, so we will have this one as 3 and this arm as 4. We'll explain that more in a while. So let's solve the problem. So Fx, which is max, so force equals to mass into acceleration, we will have the tangential in x direction, which is this direction TA. So this is our x-axis that we just saw. So we'll have this in a negative direction because we're assuming this is a positive direction where the block A is moving downward. So if this is positive, so TA is negative. And then we talked about the weight acting 10Z. So that will have a component in x direction. So we'll need this angle. So let me work on that angle. So from here, like I explained, we will have a parallel inclined plane. This is the weight acting on, if we take another parallel axis to this one and then drop down. This is 90 degrees, so we'll have 5, 3 and 4. So if we extend this, so this angle is this angle. So if we want a component along this direction, we need sine of this angle. So we know sine theta equals to this length over hypotenuse. so we will have 3/5, and this is what we put here, and the 10z is 10z. And on the right side we have mass and acceleration. So mass is 10 kilogram, that's we have here, and our acceleration is, we assume this is in this direction, so we put it a positive acceleration a. We'll figure it out whether it was in this direction or opposite direction, but we assume that this is in this direction, so we assume acceleration a, positive. So now let's move to Fy. So in y coordinate we had the normal. So if we take our, again, the block, we had the normal. So this is our y-axis, we had the normal NA. So that's this positive direction, this is positive and this is negative. So NA, and then the coordinate from here, MZ, mass Z, and then we had the triangle. Remember, we had the triangle from here, which was 5, 3, 4. So we will have cos theta, which will be the base 3 and then over 5. Sorry, we'll have the 4 and base 4 and then over hypotenuse 5. So if we plug this equation, the value of NA, so which is NA equals to positive, if this term goes on this side, positive, if you simplify 10 multiplied by 9.81 over 4 by 5, so 5, 10 cancel out 2, so 8 into 9.81. If we plug this value of n over here, and if you simplify, you will have only two unknowns, this a and ta. So if you simplify, you will get this equation, and we'll hang on to this equation. We can tell this is equation 1. We'll hang on to this equation to solve. Now we have to proceed to next step. So now we're gonna work on block B. We'll have our fx and fy coordinate. So let's draw the free body diagram of block B. So block B, you see that there is only one tension acting on this direction, TB, and there is no force acting in X direction. So will not consider the X part, we will only consider. So we start from the F equals to MA, and these are all vector, and you'll have X coordinate and Y coordinate components. So we're not considering X, we're only considering the Y. So if Y equals MAY, and Fy is only the tension upward, and then the weight of the block B downward, which will be 5z. 5 is the mass and z is the gravity. So this is downward, so we put a negative here, and 5 into 9.81. On the right hand side we'll have our MAY. So M we know mass is 5, and AB we don't know. Acceleration of B, of block B. So this is our second equation we need to solve. So we had a first one in the previous slide, second equation. Now we move on to the pulleys, because we worked on this block A, this block B, but we need more relationship, because in previous slide, uh, you'll see we had a relationship between TA. So in previous slide we had a relationship between TA and a relationship of TA with acceleration of A, and here we have a relationship in equation 2. We have our relationship of TB with acceleration B. So we have 4 unknowns, 2 equations, so we need more equations. So that's why we're gonna look for more equations. So we're gonna focus on this part of the pulley system. So DE, so pulley at D and E. So when there's a pulley and there's 2 cord and if they're all balanced parallel, so the tension of these 2 pulley is TA. They will be equal. So this is TA, which brings this one TA, and this is parallel and equal uniform pulley, so this will become TA again. So this is how we got TA on both sides of the pulley. Now on the lower part again we'll have block B pulling this way is TB. So TB, and this rope is parallel to that one and it's a uniform pulley, so this part will also be pulley. So if we solve for y, so x coordinate and y coordinate, so if we solve for y coordinate, because there is nothing on the x coordinate, so we will have 2ta equals to 2tb, which will give us TA equals to TB. We call it equation 3. So now we had 4 unknowns. Now we're getting relationship between TA and TB, so meaning they are equal. So now we have 3 equations, 4 unknowns. So let's see if we can have another equation. So now to finding the next equation, we have to deal with kinematics, where we deal with the length of the rope. Remember, we studied our theory. We have to deal with the total length of the rope of the pulley. So so these are the equation L1, L2, and N3. I'm gonna explain them in a bit. We have to take those length of the rope and take second derivative to get acceleration, and we'll get some relationship. So let's see how we get there. So the first one, we say the LAC, so the length of the rope from here, this point to here, AC, plus twice CD. So if we take this length and cut it from here, because remember we assumed in our theory of pulley that there is a fixed non-changed length we don't consider. So this length length of AC and length of CD, and this length we neglect this part because this is too small. So CD here and here, twice CD, C twice CD, this one and this one, so equals to, we assume it as a length L1. Right, now you have to consider that length L1 is always constant, because even if A moves upward or downward, then D will move downward or upward, but the total length of this rope will remain the same. So L1 is constant. So now we look for another relationship, which is L2, which is LEF. So we're working on block B. This length and we again neglect this part. And then this length, how we get this length, we assume this length same as EF and minus LB, so the length from ground. We need you remember we need a datum which is fixed, so we assume this base is a fixed datum, and we assume this length here as a length B. So if we take EF, this length, and to get this length we again do EF minus LB, this one, and that gives us the total length of this rope here, which is also constant. No matter what, if AB goes upward and downward, pulley E will go up and downward to balance it, but the total length L2 will be constant again. Now we need to work on another part, and I will show you why. We covered all the rope length. Again, we have to deal with the last length. Let me erase this part, which is the total length, the height, and we can call it CD. So again, this is constant and neglected. So this CD length up to here, and then the length between D and E pulley, we can assume it as a DE length, and the final length that we have EF here. And this height is from the ceiling to the ground is always fixed. We can call it L3. So again, L3 is constant. So now if we take second derivative with respect to time of all the equation here, L1, L2, L3, so these are constant, L1, L2, L3. So this will, taking derivative will result in 0. So if we take second derivative of LAC, which is this length, this will give us, the first derivative will give the velocity. If we take second derivative, we'll get the acceleration, so that gives us acceleration A. And 2CD, if we take derivative, it will give us the acceleration of pulley D. Same 2AE and AB, it gets us the acceleration of AE, the pulley E, and then AB is the acceleration of block B. So our goal is to have a second relationship that will act or combine with our target of fourth equation that will help us solve the problem. So if we plug our first equation here, if we plug AD equals to AE, so AE, if we plug it here, so we'll have AA equals to minus 2AE. And now for 2AE, if we say 2AE equals to AB, so finally we'll have AA equals to AB. This is our fourth equation. So previously we saw we had 4 unknown, TA, TB, AA, and AB, and now we have 4 equations, 1, 2, 3. This is the fourth equation. So if we solve this 4 equation, solving this 4 equation, we will get TA, tension A, is 47.1, and we also found out in previous slide that TA equals to TB, so that will also solve our second problem. So tension A here, and then tension B is the same, which is 47.1. And then if we solve again using this 4 equation, plug into the equation 1 or 2, we'll get since acceleration A equals to acceleration B, so we'll get acceleration A equals to acceleration B equals to negative 0.394. So we have solved the requirement tension in each chord, and we got acceleration of block A. We got the components. We got the acceleration of block A, which is negative 0.394 meter per second square. And now distance traveled by block A. For that we have to use our equations that we already know. V square equals to U square equals to twice AS. So if we use this, the final velocity, it says that before stop, so the block A will come to a stop, so the final velocity is 0. Initial velocity at this instant is 5 meter per second, so initial velocity is 5, and then twice is twice. Acceleration is negative 0.394 that we just found. And what is the distance traveled by block A? So one thing we found, the acceleration is negative, meaning block A is moving downward, but it's stopping, meaning the acceleration is negative, it's decelerating, because if you have positive acceleration it will never stop, so it makes sense. So acceleration is negative 0.394, so we put negative 0.394 to find SA, distance traveled by the block A before it comes to complete stop, and we found it is 31.7 meter. So it's easy, you have to just understand what is the thing to consider. We had 4 unknowns. We started with one block at a time. We found a relationship between TA and acceleration A. So we know we cannot solve, we need more equations. So we looked into block B, we got another relationship, TB equals to AB. Now we have 4 unknowns and 2 equations, so we look for more equations. So we worked on this 2 pulley, so we found a relationship between TA equals to TB, and then finally we look in the kinematics here to find a relationship between AA and AB. So finally we got this taken care of. So now it simplifies. If you plug it back here that we did, it simplified our problem. We're using 2 equations, we solved for TA and acceleration A, and then finally we used velocity equation to get the distance traveled by block A. If you have any question, or if you're not clear on some of the parts, just comment below and I'll explain it, or I can explain it in the class. So in next class we will solve more problems. Till then, thank you. See you in next class.